Hello everybody, and thank you for joining me again. We're looking in this video at question number 15 on our 2011 Grade 8 Gauss paper. In the diagram, AE and BD are straight lines that intersect at C. If BD, so total distance there, is 16, AB is 9, and CE is 5, CE is 5, and DE is 3, then the length of AC is... Alright, so I'm seeing right angles here. I'm seeing 3s, I'm seeing 5s, I'm seeing 9s. And just looking at the possible answers, I'm going to take a guess that the answer is 15. That's just an intuition guess based on Pythagorean triples that I know. But how do we actually approach this question if we don't just have some sort of flash of insight? Well, what could we do? So two things are coming to mind right away. One, we know this is 9, this is 3, this is 5, and they're two lines. Now, when lines cross, we get equal angles opposite each other. And we've got some right angles here. And so whatever's left over, this must be 90 minus the dot, and this must be 90 minus the dot. These must be similar triangles. Okay? So this 3 side corresponds to this 9 side, and the hypotenuse corresponds to the other hypotenuse. Now the nice thing about similar triangles is they have the same ratio. So 9 over 3 is the same as AC, this hypotenuse that we want, over 5. And now we can quickly rearrange. Multiply by 5 on both sides. 45 over 3 is AC. Well, that's 15. So my prediction was correct. We get an answer of C. Right, it was C? Yeah, C. Now, that's not the only way we could do the question. You might say, hey, I've got some right angles. And you'll notice I never used the fact that, BD is 16. Well, we can use that fact in the second way to do it. So notice down here, I'll highlight it in blue, we've got a nice little right angle triangle. So 5 squared must be the same as 3 squared plus CD squared. And if you rearrange 25 minus 9, CD squared has to be 16. CD must be 4. Okay, but if that's 4 and BD is 16, then we must get 12 over here. But look, we've got another right angle triangle. And so 12 squared plus 9 squared is AC squared. And if you need to, get your calculator out. 9 squared, 81. 12 squared, 144. Add those up, you get 225. You'll find AC, once again, is 15. Now, this is a little longer, unless you've got, if you know your Pythagorean triples, if you know sides of right angle triangles really well, you'll have to actually do these calculations, and that can take time. So, I would say the similar triangle method that we did first is probably the most preferred one. But either way, we get our answer of 15. And that's kind of nice. The answer to question 15 is 15. Kind of cool. I like it when little things like that happen. All right, so next up, we're going to be taking a look at question number 16. Feel free to join me there if you would like.